Next section is about voice user interfaces. We had a demo next door as well. I don't know how many people saw that demo where we do Blue Genie, turn on the light. Some people saw it. It's on one of the tables. Open the garage, those kind of things. I'm going to go to some market trends for voice user interfaces. I'm going to make a distinction between local and cloud computing and what that means, and then go show some solutions we have within ON, and then talk about some other technologies that fit these kind of applications at the end. So UI is really becoming, getting everywhere. User interface with voice is everywhere. How many people have an Alexa or Google or smart speaker? Look at that. Many people have that at home. And at the moment you use it to turn on the lights, turn off the lights, some sort of that. If you have a Hue connected to it, a Philips Hue or some other lighting solution.
Yesterday there was a news that now you can hack those with a laser pointer.
I didn't.
Yeah, you can actually trick the microphone using a laser pointer. People are hacked.
And what would it hack? What would it do?
Well, it takes over the Alexa. We don't have to talk to it through the laser. So outside.
Oh. Well, let me save you from that. Alexa is always listening. Although we use these words, and that's why I asked if you do the demo, we use, for instance, Blue Genie and give it a command, or Alexa, Google. Some of these are always listening, and most of them are always sending. It's almost like Google when you type something in the Google search engine that has to go to Google, and they might as well store it and see if they can use it for something else. You might search for some new patent idea you had, and they may detect that with their smart AI and think, hey, let's see if we can profit or use that somewhere else. You know, that's why in my house, my wife doesn't want an Alexa or anything like that. She doesn't want anybody to listen with it. But in our car, we use it, and it's very convenient there because it's hands-free, and you can give it simple commands, and those would be local. But medical application, industrial applications, you see it more and more. You have to be hands-free as a medical professional doing some things. You give voice commands to something that's very useful. So we'll see it everywhere. Your phone, of course, I use that all the time, where you say, you know, close by restaurants or any of those commands. It's getting around and everywhere. Nice one is the bottom one in relation with security. These systems can also hear gunshots or glass breaking for a burglary alarm. Or if all our Alexas are always listening, they can even detect if the fire truck comes by and then follow it along where it's actually going, because in every house it hears the fire truck, recognize that sound, and they could, you know, go in the cloud and make some algorithm and do something and see where the fire truck ends up.
As long as the fire truck says Alexa.
No, it doesn't. That's the whole trick. It's always listening. That was our whole premise of this stuff. We just been told we have to say Alexa, but it's always listening in the background. And companies may be commercializing that or doing something with that by giving local radio stations a notification if the fire truck is driving somewhere. You know, you could sign up for that. I don't know if they can monetize that in some way. I just come up with these things while I'm thinking about it. Earlier I thought about the MEMS sensor. If you walk around and inside the coverage in a building, it fills in steps counting and moving in different directions. Fireman could go into a complete pitch black building, push a button, and it would from that onward track them where they move. And then if they need to go back out, they push the button again and they would hear in their headset a beacon pinging where they need to go next. No, so not where the door is necessary, but how to get around the obstacles, how they got in, basically. So you can make many of these applications. You could do something with scuba divers underwater, finding their way back to the boat, to the dive boat, or any of those things. So there are many, many different solutions, and and applications for location-based services and all these other sensors. Voice activation is a natural human interaction. In the beginning, there were some resistance to that, where people, sometimes feel hesitant to talk to machines, but that's really going away, and the natural way you interact with these solutions makes it now to the point where this is taking off. And that's the message from this slide. So if you look at the market trend in the top left, it's 2019, 2022, they predict a doubling of this market. So whatever is there already, all those wireless speakers we have, this is and voice-controlled services, this is going to double. Interesting thing here to look at as well is the players are not changing, so they're scaling with this as well. The big guys that have this market, just going with it and scaling with it. Here in kind of an interesting one in top right is that home automation is one of the real growing sectors there as well, with some quantifiable data to that. So lights, controlling lights at the moment, but going forward there's a solution already where your fountain or your water faucet will come on when you give it a command, a voice command. There's some products out like that. There's a microwave that apparently works with voice activation. If you now also make a cooling element in it, you could just put your frozen food in it, come home and have it, while you drive home, you click on the button and you give it the command to heat up your frozen stuff, food, and it's ready when you get home. I don't know if I want that, but it's possibilities that could happen. If you look at a system, and the takeaway from this slide is really we can do local processing and we can do it in the cloud or a combination of the two. In general, the solution we will talk about later on, we have a embedded voice product that allows us to have multiple inputs, so you can do functions like beamforming or follow somebody that walks around, and also noise cancellation. So several different algorithms that we bring in our products that can assist by making it a better experience for the user, are all embedded in the product, and you can just use out of the box. This is in general a loop locally, and in the local loop we'll go into some details in a minute what you can do there. Of course, if we go off into the cloud, then we're in Alexa, Google, and all these companies' territory. They have IBM Watsons in the background to analyze whatever you intended to say and can respond to that. These local systems do not have that. So that's one of the big differences between the two. And here's the list of many other things. So another one is latency. So for the local system, there's of course less latency. You don't need to go to the internet. It has a local response, so that's why you see it in car systems, in medical solutions, anywhere where you have to have low latency interaction with a device. You will use a local processing and a local recognition of the commands and then add to them. They mostly are then a simple, I wouldn't say simple commands, but they're a restricted list of commands. So it's like play, stop, start, those kind of things. And if you go into cloud computing, it becomes AI, is there, and everybody that can help you with analyzing what you meant and want to do. So there are way more complicated solutions there. Portability, again, for local processing, no restrictions. I don't need an internet connection necessarily. So you can also use your battery power, again, more efficient. You don't need a Wi-Fi solution or Bluetooth to go onto your phone or anything into the internet. You can do it local. Yeah, and many others. Of course, our reoccurring theme, power consumption. For local, low. For remote, it will be higher, including the cloud computing, what you do. This highlights again some of the algorithms we use and in our solutions, in the specific solutions we have today. And we'll go through them in another slide. I'll skip over them. So again, the distinction between local and cloud-based. So local is some kind of a device that gives controls through turn the lights on, start the garage door opener. That's the demo you see next door. We have a demo where you give it the device a local, you see a motor run, open the garage and the motor starts running in a certain direction. Close the garage and it runs in another direction. So those kind of examples. And also for water or other solutions. The position there, the LC823450, so the last digit is different between the cloud and the local one. So there's two products we use in this space. The second one, the 55, has some more, one of the changes is some more memory. So you can have some more buffering and other algorithms to run there to facilitate Bluetooth speakers or smart speakers in these kind of solutions. I already talked about some of these. So for the local solution, we have now kitchen companies that come on with faucets that you can turn on the faucets with your voice. Washing machine control, window shutters, air conditioning, appliances, lighting. Different lighting is of course the prevailing and the use case that most of us may have in our houses. And it will get just wider accepted and used. In the home, it's really a convenient play where in the industry, like medical settings or others, it might be necessary to keep your hands free. Here, it's different. It's really targeted to convenience and easier interact. So this solution we have has a dual core, M3 Cortex, and it has also a DSP. So it gives us a lot of flexibility to run our own algorithms, as I showed up there, noise cancellation and beamforming and all those types of things that we do in our application. And then in addition, run the customer's applications. So it can be used for that as well. And we have different inputs and for the mic, for the speaker. We can even go to I2S to some of our products which are Class D Amplifiers and go to bigger speakers or louder sound solutions. We touched on this as well. So the demo you see, limited vocal user interface, fixed commands. And if you want to change these commands, if you're in a local loop, you have to go through some work with the company or with us to direct you to the company that will allow you to make these files for the recognition of the commands you want to use. And so that's with local systems a limitation. Here's two examples of a home automation and of a music player. In general, these functions are very static, they're fixed. So it's a natural fit for these kind of commands that are universal and are used by everybody. And then we have a block diagram of a solution that incorporates all the green parts are on provided solutions. So we do the power in this system. We have Class D amplifiers, and we have some other solutions that would enable you to have a complete system and a reference design for applications in toy, robotics, as well as white goods and home automation solutions. Demo is next door. Definitely look at it. It gives you kind of an idea how sensitive it is to voice, different voice without training. It recognizes even my accent, so it's pretty good. But it is a local system, and we use the phrase, hey, Blue Genie, to wake it up. And then you give it the command, so open the garage, and you would see this motor start turning to open the garage. or turn on the light, and there's a light back here that would turn on, etc. Then we come into this cloud, where we go with our sound phrases into the network, and that then gives us all these, what's the weather in Los Angeles? All these natural language or more complicated sentence structures that somebody can analyze in the cloud and then tell us back if we need to take any action on that or do something with our device. Of course, it gives you a lot of flexibility because it's more natural language. It's easier to adopt to different languages, different dialects, etc. But it also requires an internet connection and going off and using Amazon or Google or any of those kind of services. So we have now a router or something in between that goes off to the network. If you would have an Alexa speaker and you turn off your Wi-Fi to the speaker, you can Alexa anything you want. She would just say, I momentarily cannot assist you, because she doesn't have local capabilities. She always relies, or that system relies on that. So it's always good for some of that, depending on what your solution is, where you're working for, to have that local capability to do turn on the lights, turn off the lights, and some of those activities. Then this is a more complicated or complex solution we're going to demo at CES. It's a large smart speaker, maybe something like it. There is a 40-watt bass speaker here at the bottom. This thing is about this high, and I think it grew a little bit out of proportions. Some of our audio enthusiasts got involved. It has 4 speakers and 10-watt speakers in the top here, and then it has this board which has the 55 on it, and you can use it as a wireless, so you can stream to it and play music, but it also is integrated with Alexa, finally AMA, but initially now it has our Bluetooth, the Bluetooth Genie application, where you can start and stop and give it commands. And it uses some of our other technologies that we'll come to at the end, like USB power delivery and others. Which is, so in general, this is really a demonstrator, because it's kind of quite big and quite loud. We'll have a version of this later on as a reference design, like we have our normal platforms or reference designs. We'll probably have just stereo, which gives us all the functionality we want to demonstrate with that platform. But yeah, you can build something like this. You can stick it in your washing machine or washing room and have it do echo cancellation. Probably with a speaker like that, you can overwhelm the washing machine and counter sound it so it becomes more quiet. Who knows, whatever the application may be. Interesting solution. I just saw the announcement of Alexa. They announced a bigger speaker that would be with your TV. So it would do movie sound, kind of what they look at. So that they already go to a bigger sound solution for those kind of applications. We do have a Alexa connected reference design. It's not here. It's at the demos. And so that's using like your wireless Bluetooth speakers or your wireless smart speakers at home, Alexa enabled system. There's a reference for that. The key there then is we will look at some of the power numbers or do measurements on these systems, how efficient they are compared to other people's solutions. And again, on the power delivery and power efficiency, we get 50% power consumption or power efficiency compared to other systems in the same area. So really focus on power safety, of power efficiency and power saving power in these kind of solutions. One of the things there is, of course, also standby power. If you don't speak to it, what you can do at that moment and have triggers when you need to listen and those kind of things. So it's more than simply using the most efficient components, which definitely helps you in these systems. This slide is kind of an overview of all the different things I just talked about, what we have in the area of less than 10 watt, more than 30 watts, microphone, preamps, and some of the other solutions. Just go over it, and if you have any questions to it, please contact our FEs or partners, and the question will get to the right person and help with your solutions. So then we have Type-C power delivery. This technology came about a couple of years back, and it's now really proliferating. I saw some first automotive solutions, some cars with a Type-C connector that would charge from that connector, and it's up to 100 watts. In automotive, I don't know in the specific case what they use it for, but you can basically set limitations on your port, and it's more than the 5 volt that you get now out of your current Type-A connector, and more current as definitely as well. But you can set it, and it can balance the ports. So if you have one device that wants more power, it can negotiate that. There's a whole protocol around it, and we have a solution for that is very small in size and helps, and very again efficient. It's a team that is reoccurring to give you a power delivery solution with USB. And then our Class D amplifiers. Who is here in the room, audio Class D amplifier interested? Okay, good. So then I will skip over them. I'll say 1 or 2 things about them. We have really good solutions in it, and one differentiator is this additional circuitry we have to actually listen to the speaker, as you will, sense what the speaker is doing, if it's overdriven or other characteristics, and then be able to compensate for that and drive it the right way, so you can get a longer life out of the speaker, and it works better in different enclosure solutions. You can even use it to tune it to your enclosure that you create for that in your laptop or any environment. So there's benefits in production or in factory automation, or when you create these, to have quicker analysis of the speaker is working as it should be. And then during mission of driving the speaker, you can make sure it's not overdriven, and it gives you a longer life of that device. Okay, Alexa, who is familiar with AVS? I think many people have voice services, Alexa voice services. Like Amazon came out with AMA. Anybody familiar with AMA? Just came out. That's Alexa mobile accessories. This is a new standard, or relatively new standard, where they put the processing power, additional processing power that's required for these smart speakers that you now have everywhere that do AVS and are AVS certified. Some of that required functionality goes to your mobile device. So Alexa makes an application that would run on your mobile phone, and then the mobile accessory or low power as well, lower compute solution would communicate only over Bluetooth. So there's no Wi-Fi going into the cloud, there's only Bluetooth going to your mobile device, and then your mobile device would make it again an AVS system going into the cloud. And that's a very natural fit for us, because we're focused on power, and this will give you a lower power solutions, because you offload that functionality to your phone, which you have with you. Again, in the scenario that you see here, we have earbuds and headphones and solutions that are around the body. It's a very natural fit to go to your phone with that. And this AMA will be the demonstration we will do eventually in probably Q1 next year with the smart speaker we just saw. Some examples of products, some success stories where we used this technology. So the CPUs, we went over the 50 and the 55, earbuds, voice recorder, and etc. So they're out there. And then some where this is a natural fit. So music players, voice recorders, sport, toys, lighting, I think all the usual suspects that will get some form of voice control or voice user interface will benefit from our solutions. So key takeaways. I think personally as well, voice and gesture are two things that are human, natural options to interface, and they are coming, they're enabled by having the right technology out there at this point. And we see some, in voice we see a lot, in gesture you see now in cars coming up with voice up, voice down, systems that can be that fine-tuned and looking at your intentions. There's even some that can read sign language now, you know, distinguishing to that grade. And so they're becoming very enhanced. And this also is in relation to our sensors and LiDAR or short-range LiDAR that they use in these applications to add to your video signal depth or depth detection and inside the car instead of, you know, the ones that go outside of the car and looking around with LiDAR, which we also look into and work on in conjunction with radar and video imaging solutions. So voice, very natural for humans to interact in, but we heard that for many years. But now I think it's really working for several years that you start using it and it benefits you in your work in some applications. Not all. I don't see myself yet Google with voice, but it may come. Of course, on my phone, finding a restaurant close by, finding a gas station close by, that works very nice. But doing research on Google, you know, using your voice, I haven't used it that way yet, but it will be interesting to see where this is going. But definitely in the home, many things will be voice controlled as another convenience level. And I think we have some nice products to be in that space and to help you out if you work on some of the solutions in that area.